Today's video is on a tech thing, a technology that Mclaren Elva uses. The technology is called Virtual Windshield, and today we are going to dig deep into its technology, into its fundamentals, into its systems, its components, and overall things that make the system work. For demonstration, I am drawing a picture of so-called Mclaren Elva, and we will try to see how does this system work. Okay, so we have drawn a basic diagram, a representation diagram of so-called Mclaren Elva, and now we'll see how this actually works. So here's how this technology works. So this technology consists of one duct, one air channeler, okay, and one is the angled deflector, which is static in nature. It doesn't move actually. So we have basic three components. One is the duct in front. Second is this air channeler, okay, and the third is the static air deflector. So inside this air deflector we have certain air vents, okay, which are angled at certain position to redirect the air at that particular angle. And the third and the fourth thing is, which is the most important thing and which is the most interesting thing technology wise, is the dynamic deflector right here, right? So we have the dynamic deflector right here, which pops up at speed greater than 30 or 70 mph, right? Okay, so this is the four components comprising making this virtual windshield technology possible, and here is the science behind this. So to understand this, I will recommend you to read a little bit about Bernoulli's theorem, a little bit about the Venturi effect. Okay, so Bernoulli's theorem says that if you increase the velocity of air, then you will have decrease in the static pressure of the air, and if you decrease the velocity of the air, you will have increase in the static pressure of the air, right? And what is Venturi effect? Venturi effect is nothing but Venturi effect can be written in mathematical terms as A1 V1 is equal to A2 V2. Okay, so if you take this, so Venturi is shaped like this, a converging diverging section. Okay, so we have this area 1, so we have this as area 1 and we have this as area 2. So you can see this area has a larger opening, like larger diameter, and this has smaller diameter. So at this area we have higher air velocity and hence greater pressure drop, and this area has lesser velocity and hence higher pressure. So this is what this Venturi effect is, and this is what Bernoulli's theorem also says, right? Now what is happening is, since when the car moves, it penetrates the air in front of this, right? And because of the movement of the car, the air rushes in this duct, the front scoop of the car, which you see like a monster face in the car. Basically it's a duct. So because of this duct, air is rushing inside this channel, and this air, because of this channeler, is forced to go through this path, and these deflectors are channeling the air in this direction, right? And this forcing of the air in this particular direction disturbs the oncoming air on the top of the car, and because of this disturbance we have this virtual windshield. Very easy. Now one more thing. And what happens because of the deflector? Now coming on to the deflector part, what happens is, when you open up the deflector, so at higher speed when the deflector pops up, what this creates is, it creates a blockage, right? If I go to the zoomed image of this, so what will happen? So this is the front of the car, right? So we have this deflector placed on top of the car. Now we have a dynamic deflector which has popped up like this, right? So as from this deflector, static deflector, the air was channeled in this direction. Now what will happen, because this deflector has popped up, so even more air is coming out of this particular static duct. Why? Because since this is So since because of the higher air velocity from air velocity at this particular point, as I already told you, because of the Bernoulli's theorem or continuity equation, so when you have higher velocity here, then obviously you will see some pressure drop, right? So because of this pressure drop, this creates a suction effect. Okay, so this will even suck more air out of this channel, air channel. So what this creates is, this creates a virtual suction zone, and this will pull in more air from the car. And since we are deflecting the air at certain angle, and this is disturbing the oncoming flow, right? And because of this deflector, this leading edge also is disturbing the air, right? So what will happen? Now we have two effects superimposed, like plus. One is this deflector causing this, and other is the dynamic deflector. So when the air hits this deflector, then at the leading edge of then the leading edge of this particular deflector is designed in such a manner that it will also deflect the air, right? And these two effects, when combined, this creates a tremendous amount of disturbance to the air coming from the front, and this is how you get an air profile like this on top of the car. So you have this virtual zone, virtual bubble zone, or you say virtual zone, where there is no direct wind blast, and this is what we want, right? So because of this no direct wind blast, you do not have any air hitting your face when you are driving McLaren Elva.